Good day. Our topic for today is all about work and power. So let's start with this question. What is work? In layman's term, maybe we will be thinking that work is an activity involving mental or physical effort. Or some of us, it means earning income. But in physics, we will have this definite definition. Work is done whenever a force moves something. So what do I mean by that? Okay. To know more, let's have these slides here. So we have conditions for work to be done. First, there must be a force acting on the object. So I want you to look at this man. He is pushing this box. Okay. So let's check. Is there a force acting on the object? Hmm. So I think the main question here is this man has done a work in this box? Again, is this man has done a work in this box? So there must be a force acting on the object. So check. Second, the object has to move a certain distance called displacement. So notice that this man is pushing this box, and you will ask if once this man applied the force in this box, is this box moving? Yes, it's moving. So condition number two has been met. And last, there must be a component of the force in the direction of the motion. Means the object must move in the same direction as the force. So again, the main question is the man has done work in this box? Condition number one, is the man pushing this box with a certain force? Yes. Condition number two, is this box moving to a certain distance? Yes. And three, is the component of the force and the direction of the movement of the box is the same? Yes. So therefore, in this kind of situation, the man has done work in this box. So work is done when a force causes an object to move in the direction that the force is applied. Okay? And mathematically, it is expressed by this formula. So force multiplied by displacement or distance. Or you can break down the force, okay? Because force in our previous discussion, especially about laws of motion, that the net force is equals to mass times acceleration. So if we're gonna substitute this ma here, okay, it will become this one, and then copy the displacement. Here are the physical quantities, their symbols, and their units. So you have to familiarize this one. So you have to remember that you're going to use this formula if it's horizontal, meaning it's from like west to east or east to west or like the x-axis, okay? Because there is also a formula for vertical. Okay, so we have this. So mass times gravitational acceleration. So you already know this one, the g, which is the 9.8 meter per second squared. And in what direction? It always points downward. So what is joules? Okay, joules is defined as the amount of work done on a body by 1 Newton force that moves the body over a distance of 1 meter. It is named after James Prescott Joule. Okay. At this point, we will have a very short activity. Okay. You have to tell me if if the given situation is doing work or not. Okay, here. Let's go to sample number one. Is this woman has done a certain work in this two box? Okay. First condition is this woman exerting a force in this two box? Yes. Okay. And in what direction? Okay, that would be upward. Upward. Condition number two, are these two box, okay, move to a certain point? Yes. Okay. It has a displacement going in this direction. Okay. And condition number three, are there components or is there component of force being exerted to this object, so these objects, the same with the direction of its movement. So look, so the force is going up, but the displacement is going in this direction. So condition number three has not met. Okay, so no. Okay, there's no work done by the woman to these two bags. Here, okay, as this woman, I think, okay, exerting a force. Yes, it's going up. Okay, and what's the direction of her movement? Yes, it's also going up. So therefore, in this situation, there's work. How about this one? And this man is pushing this column here. Is there a force being exerted by this man to this wall? Yes. Okay. There is a certain force. But how about, is this column moving? No. This column is not moving. The displacement is, oopsie, is zero. Okay. So is zero. So therefore, even though you exerted a lot of force, but there's no movement, then it's not okay. So this man hasn't done any work into this column. How about this SpongeBob? Okay. The question is SpongeBob has done work to these two cute, what's this, bunny or teddy bear? Okay. So is SpongeBob exerting a force? Yes. Okay, it's going up. Okay, how about with these two objects? Are they moving? Yes. Okay, from the ground up to this point here. Okay, so in short, um, SpongeBob has done certain work with these two cute stuffed toys. Okay, that's it. We're done with the concept solving. Now let's go to the problem solving. So this is a very simple problem solving. The question is, how much work do you do by pushing a sack of rice with a force of 100 Newton across a distance of 5 meters? So in solving problems, we have to start with, okay, the illustration and then the given. Okay, so the illustration, this would be like this. If this is the sack of rice and it was pushed to a certain distance, which is 5 meters. Okay, we have here now for the given force, distance, okay, and we have also the one being asked. In this case, that's work. And then we have this formula. Now I want you to look at the given because the movement is horizontal, so that's why we have this formula here. If it's vertical, we will have another formula. So if it's horizontal, we have this. So we already have the force, we already have the displacement. So just pure substitution. Okay, and when you combine nm, okay, Newton meter, it will turn into joules. Okay, so the answer is 500 joules. Next would be a man push a 40 kilogram box, accelerating it at 1.5 meter per second squared for a distance of 12 meters from rest. So neglect friction, find force. So we have here 40 kilogram from this. Okay, that's the mass. Next would be the distance. Okay, and the acceleration here. Okay, now the first being asked is the force. Okay, okay. Then we have the formula. Force, the net force is equals to mass times acceleration. So we have now the mass and we have the acceleration. So just pure substitution. Okay. And when you combine kilogram per meter per second squared, it turns into Newton. So I hope that's clear. You just simply multiply these two numbers and you'll get this 60 kilogram meter per second squared. Now let's go to this. So the same given, but there is an additional from the previous one, which is force. Okay, and we already know that's 60 Newton. So we have here work, and remember the in this problem, it is a man push a 40 kilogram box, okay, accelerating at 1.5 meter per second squared. Okay, so it's still horizontal. So we have to use this formula, force times distance. We have force here, we have distance here. Okay, and when you multiply these two numbers, you get this. And then when you combine nm, it becomes joules. So I hope this one is clear. This is just simple problem. Okay, what happened here? You just purely do substitution and then you multiply and you get these numbers. Next concept, that would be power. So how powerful are you? So what is power? Power is a quantity that tells you how fast work is done. Okay, power is the amount of work done divided by the time it takes to do that work. Mathematically, it's expressed by this. Okay, so work divided by time. So it is your rate um, of doing work. So it will tell you how fast are you when it comes to doing work. So we have also this formula. How do we get from this? Okay, remember if this is power, okay, when you break down work, it becomes force multiplied by distance over t. So in this case, okay, we have now the force here. And distance divided by time. Okay, we have this. Okay, when you combine this two, it becomes this. So I hope that's clear. And then it's the rate to which work is done. Power is measured in joules per second or watts. It is after James Watt. Okay, so you have this formula here. So is doing greater work different from doing work faster? Let's find out. So I have here my two friends. We have Jake and Ju. Okay, Jake, okay, carries a 50 kilogram barbell. Okay, 50 kilogram barbell. It's like one sack of rice. Okay, and from a distance of 1.5 meters of the ground up to here, up to here. Okay, that's 1.5 meters. Okay, and how fast? Uh, he did that in just 1.2 seconds. Okay, next we have Ju. The same thing, this barbell here weigh 50 kilogram. Okay, and he carried the barbell from the floor to up to here. It's 1.5 meters. But it took him 3 seconds to do that. So I want you to compare the work done by Ju and Jake. And next question, this is the first question. Second question is, who has done his work faster? In short, who is more powerful? Hmm. So we have here Jake and Joe. Both of them has carried a barbell that weighs 50 kilogram in a distance from the floor that's 1.5 meters. With a time for Jake that's 1.2 seconds, and for Joe that's for 3 seconds. Okay, and since they pick up the barbell from the ground up, going up. Okay, so we have to factor the gravitational acceleration because later on you're gonna use this one. Okay. Next is the first being asked is um, who has done more work? So that's the question, who has done more work? So we have to find work first. And since it's vertical, so we have to use the formula for vertical. So we have this. So you have to review your notes and you will find it. So do we have mass? Yes. Do we have gravitational acceleration here? And do we have the height or the distance? Yes. Okay, well and good. The same thing here. It's the same thing here. Okay. Now, so pure substitution, 50 kilogram for the mass, 9.8 meter per second squared for the gravitational acceleration, and for the height or distance, it's 1.5 meters. The same thing with Joe. Okay. So the question is, who has done more work? Yes, they both uh, have an equal work done. Okay. So they do the same amount of work, which is 735 joules. Okay. But the next question is, who is more powerful, or who has done the work faster? So we're looking for power. Okay. And power in a previous discussion is defined by, or is mathematically expressed by, work divided by time. Okay, so do we have work here? Yes. Okay, then the time, use this time here for Jake and time for Joe. Okay, and then you get this number. So who has a greater magnitude of power? We have Jake. So we could conclude that Jake is much powerful to Joe. It means he can do the same amount of work but much faster. Okay, I think that's all. Thank you for listening. Enjoy your day.